doing this? Putting this in your calc? Everybody can put this in his calc? A decimal place to around him? 3. 3 decimal places. Okay, these guys, get used to doing these without your calculator as well. Get used to doing your transformations. You guys are really, really good on transformations. So get used to doing these without your calculator. All right, so this is your chord or your parent graph, base 5. It just comes a little bit sharper than a base 2. Okay, and a little bit closer to the axis. Again, the domain. The domain is all real numbers. The range, you can't use 0. There's your asymptote, intercepts. We take the negative, use your transformation rules. When you negate a negative, if you put your positive to your negative, you're a reflection over the y-axis. Use your rules for that. It's just going to make this a decreasing function. Everybody good with these? Base 3, same thing. Base 3, same format. Remember, you're sketching. So all I want is that smooth little curve going up. Okay. Increasing, decreasing, kind of the same thing. God bless you. Get used to the sketching part. Okay, you had to match these. I don't know what happened. Something got messed up with my ink up there somewhere. I think that belonged to the thing up on top, so just kind of ignore that writing. I must have moved it down. So these matched up, okay? By your transformations, everybody good with these?
Yeah.
Good. Pretty basic, right? Just to get you back into exponents and logs. Okay, so here we start with your parent graph, basic core function, and we do an x minus 5. Remember, when it's next to the x, it's a horizontal. Make sure you say horizontal shift. I want the horizontal word in there. Find your new intercept. This is important. Did the directions say find your y-intercept? Yeah. Find your new y-intercept. You plug your x in for 0. We can't find your x-intercept yet, so we didn't turn this into a log yet. So the x is an exponent. The variables in your exponent the x. So this way, if we're finding your x, we have to turn this into a log. We didn't get to that part yet, so I'm only expecting you to find your y-intercepts right now, not your x. When we hit the logs, we'll find your y's. We'll find your x ones. Again, off your core graph, as if you put this in for an x first, you have to do a horizontal shift, and then you've got a vertical shift. Okay. Keep track of your asymptote. The one that's going to change your asymptote is which one, your horizontal or your vertical? Vertical. So, and that's going to change your range as well. So your vertical shift is going to move that thing down 3. So if you were a y equals 0 before, you're going to take 3 away from it. You're now going to be a y is equal to negative 3. Okay. Where's the rest of it? Down. Is that the last one? Okay, good. Okay, so your y is equal to negative 3. Find me your new y-intercept. Okay. And everything should make sense. It should all fit together. It should make sense. Okay? Good? Any questions on the homework? No? Good. Nice, easy. Good, very good. So, they ran this algorithm thing over and over and over, and theoretically, your natural log approaches this number right here. So technically, that means this. If I was to draw my x equals 2, my x, okay, if I was to draw a 2, and then I was to draw a 3, be a little bit quicker into there, a little bit sharper over here, still crossing the same ones, my natural log would be very, very close to my 3. A little bit inside my 2. It still is an exponent. It still behaves as an exponential function. Because instead of I've got y equals 2.7 blah, 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 blah to the x, which is my natural log. So it behaves just like any other exponential function. I just want you to get that it just behaves the same way as everything else does. It just is what we call a natural log. Do you have to know that formula? No. Do you have to know what the numbers are? No. But just kind of so that you understand that it falls somewhere between a 2 and a 3, a little closer to a 3, and it behaves just like any other exponential curve does. It's still going to pass through, it's still going to have a domain, it's still going to pass through, it's still going to have a range, it's going to be an increasing, it's going to behave the same exact way. Okay, and I don't expect you to memorize the number or the formula. Just kind of be aware where it goes. Now, just like when you did anything else, you can put this in your calculator. Everybody know where to find the E? Okay. Above the caret thing. Where did you find it? It's above the ln. It's above the ln. I don't know if you'll be able to see it on this calculator because it doesn't ever show up good. Yep, that's your natural log. E to the x. Oops. Oh, I want you to use e to the x because you're going to be using this guy whenever you raise it to the power. So if you're just going to put that in your y equals again, do the e to the x. I forgot the 2. And just put this in. Works the same way. I just forgot the 2 in front. So it works the same way. You're going to raise e to the special power. I think you should. Everybody can find e. Use this e rather than use the e with the caret thing because it makes it easier. It already brings it up there for you. So that's what I want you to be using for those. The e. Who's not listening? Where's my calculator? Okay, so here, if I'm putting this in, my e raised to it, you can't really see it on this calculator, but it's second ln. Second ln, and you're just going to put it up there. It already brings it up top. It already brings it into the exponent. It's e to the x. It's above your ln. And it's aptly above your ln because when you take the log of that, for base e, you have to use your natural log. So you have to use the ln versus log. You can use e, you can use your ln all the time. You don't have to use log ever. You can use ln all the time. But for an e, you must use ln. And you can put these in and you can sketch these. They look like normal sketches. Put them in your y equals. How do you do what? Put it in your y equals. They behave just like a regular exponent does. Kind of like close to the 3, if you will. So this is going to say, this 2 just multiplies your answer. So this 2 is going to cross here. Instead of 0, 1, it's just going to cross here. But it's going to have the same look. Here's a negative, and it's a 1/2. So it's going to be closer to, if I multiplied my 0, 1 times 1/2, I'm going to be at 0, 1/2. And it's going to go the opposite way. So they're going to behave like these. Remember, you're just sketching. So I just want you to be aware that the natural log works just like any other exponential function does. This out in front, this has an effect on it, like and mostly you can see it where the intersect is. As long as you can do that, we're good. Okay. Next is your favorite part, compounding. Now, before we start, write this down. This is the format that you're going to remember to use whenever we use an exponential growth or decay. Growing, adding interest, whatever we're doing. This is your original amount. B is your rate. is time. Everything works off of this. Even these do. Because this is your A, your principal amount. This is your B, this is your rate. This is your time. Everything works off of A, B to the X. Every exponential growth or decay that you're going to see here. A decay is going to do a minus. If it's a decreasing, it's going to do a minus the rate. Hopefully you won't lose money. Hopefully you'll always be gaining money. Now, your basic investment formula is this. The one we usually use is this. Now, the only difference here is the n. When n is 1, if it's annual, then it turns into this formula. Because n is 1, so I don't have to have a fraction, right? And I don't have to have a 1t. So that's this basic formula. That's where this comes from. This is the one you probably were using, right? And n is how many times a year you calculate this interest, compounding. Okay. And n will say if it's monthly, what is n? 12. If it's daily, if it's quarterly, if it's semi-annually, 2. Okay, if it's daily, quarterly, these are the ones, right? Daily, quarterly.
What's
biannually? Biannually, 2. They say semi or biannually, 2. Anything that's continuous works a little different. This is your E. Daily, monthly, quarterly, weekly. How many weeks? How many weeks? 52. Okay, so these are the numbers we're going to use. 365 for days, 52 for weeks. They're all going to fit into this. Now, when we do this, if it's just an annual, compounded yearly, we can avoid the n part because n is 1. But for the most part, it's going to work off of this formula. This is your A, how much did you invest? This is your B, this is where your rate is, and this is your time. So they all have the same look that this one has. A, B to the X. Okay. Yeah, you kind of have to remember that formula, but it's not so bad once you get used to using it. And PERT is your continuous. That one works, as soon as they say continuously, we do PERT. PE, raise it to the RT. Okay. So let's try one. Given we invest $1,000 at an 8% interest rate, which you'll never ever see. After 1 year, what is the value of the interest compounded annually, quarterly, monthly, weekly, daily, continuously? So we're just going to set this up a couple times until you see what's changing. Continuously is E. Perfect. That one works differently. This answer will be very, very close to your daily. 8%, our percentages are high that we use because, of course, we want you to see a difference in money. These percentages obviously are not real life because there's nothing that will give you an 8% return.
What's like the average return?
The average, maybe, like if you have a savings account, do you ever look to see what you earn on your savings?
Yeah,
It's pennies.
I get about 8 cents a month.
It's pennies. 8 cents a month is not even bad because it's pennies. But like maybe a CD might be 2%, maximum 3%, but the interest rates are very low. But for our purposes, they're higher because we need you to see growth in here. So you're going to take your interest and you're going to make it into a decimal. You're going to start with your principal. My advice is lay out all your pieces. Your interest is your interest rate, that's your R. Make sure you turn it into a decimal. Your time is what? What is your time on this?
For the first one, it's just
For all of them. For what is your time for all of them? 1 year. So your time is 1. You're gonna. I want to know after 1 year how much did I accrue? What do these guys represent? What variable? N. This is your N. So annual N is 1. Quarterly N is 4. Monthly N is 12. Weekly and daily. So let's just set up a basic formula. So we're going to accrue, meaning accumulate. We start with 1,000, and we're going to say this is an annual. I'm just going to use the N in here so that we can continually use it all the way through. Here's my interest rate. My annual means N is 1. N times T, which is going to be 1. So how much money did I accrue after 1 year? Now, the way this works is this 1 plus, all it does is roll your interest in. So for instance, if I gave you $100 and I say every day you earn 10%, how much do you earn after the end of today? 10%. $10. So what do I do with this $10? I add it in. Tomorrow you earn 10%. How much did you earn? $11. So I have to keep adding this in. What the 1 plus this does is automatically roll it in. This is 1. This is 100%. Take my amount and add it to 10% of that amount. It just rolls it in so that you don't have to come over to the side and add it back in. So that's why everything is 1 plus this, because we're rolling it in. If we were going to decrease that, we would do 1 minus that. We would be decreasing it. So all you're going to do is throw this in your calculator. Agree? So you're going to throw it in your calculator and you're going to come up with $108. $1,008. 1080. I have 100 on mine. I don't know why. Okay, so 1080. This is what you made after 1 year. So what happens now if we switch this to quarterly? What do I have to change? The N, which is here and here. So quarterly, I'm not going to do all of them, just so that you see a pattern. So I'm going to say 1,000, 1 plus 0.08, here's my N, and here's my N up here. Here and here. And you're going to put this in your calculator. Everybody good with doing that? Okay, so now if I change this to daily, what's it going to look like? 1 plus what? 0.08 over 365. Raised to the 365. I'm just going to say times 1 because that's our time right now. Good, so everybody sees the pattern. Now, continuously is a little bit of a different animal. Continuously says you have to use per. So you invest $1,000, you put your E, your rate is still the same, 0.08 times 1. So put that in your calculator. That's going to come out very, very close to your daily one, a little higher. That'll be the highest one you make because it's continuously. So what do you get for that one? Anybody get something for that one? Okay, so since this is money, we have a special kind of rounding for this. Money is rounded to how many positions? 2. So we're going to round this to 2 positions because it's money. Okay? So everybody see this? Good? All right. So you should be okay with tonight's homework. Just know this formula. Remember, everything works the same way.